All right, everyone, get ready, cause today we're taking a deep dive into the science of sound acoustics.
Oh, cool.
We're going to figure out how sound waves do their thing, how different materials can like muffle or crank up those sounds,
Right.
and what actually makes for good acoustics,
Right.
or, the kind of make your ears want to explode.
Yeah, yeah. I know what you mean.
It's funny how we don't always think about sound, but it kind of rules everything,
It
right?
really does.
From how we talk to each other to like how we feel in a room. It's all about the sound.
Yeah, and it's something we often overlook until it's bad, you know.
Totally. And you actually gave us some awesome stuff to dig into for this deep dive, like lecture notes, technical explanations,
Yeah.
the whole shebang. So we can really break down how sound works, especially when it comes to walls and floors,
Mhm.
the stuff that surrounds us.
Right, exactly.
So one thing that really blew my mind from looking at all this stuff is like the crazy range of human hearing.
Yeah.
Think about it.
Yeah.
A tiny whisper to like a jet engine taking off.
Yeah.
That's a huge difference in sound
Oh,
pressure.
yeah, it's a million times.
Million times. That's wild.
It's a lot, yeah.
So how do we even measure that?
Well, that's where the decibel scale comes in.
Right.
It's logarithmic, which maybe sounds kind of complicated,
Yeah.
but really it just helps us get a grip on those massive differences in sound energy. You know what I mean?
Right.
It's not like an even scale.
Okay.
An increase of 20 decibels actually means the sound energy is like 100 times stronger.
Whoa, 100 times.
Yeah, it's exponential.
Okay, so it's not just like one step up. It's like
Yeah.
it's like whoa, way louder.
Exactly.
Okay, so it's like a zoom lens on a camera, where you can see both super tiny details and these huge landscapes.
It's a great way to think about it, yeah.
And it can adjust for both.
Exactly, yeah. And those sound level meters, the things that measure noise,
Yeah.
they use something called the A-weighted decibel scale,
Okay.
which is also known as dBA. And what's cool about that is it's designed to be like how our ears hear loudness.
Oh, wow.
So it takes into account how we perceive it, not just
Right.
the raw energy.
That's super clever.
Yeah, yes.
So it's not just about like how much sound energy is actually out there. It's how we experience it.
Right. Precisely.
Yeah.
That's exactly it.
So, okay, let's actually talk about sound itself.
Yeah.
Like, what is it? I mean, we're talking about waves of pressure, right?
Yep.
That travel through the air. Kind of like if you can imagine ripples in a pond, but you can't see them.
That's a great analogy. Yeah. And just like ripples carry energy, each sound wave carries energy too.
Right.
In fact, sound power is measured in watts,
Okay.
just like electricity.
Whoa, I never thought about it like that.
Yeah, it's all about energy. It's just, a different form of it.
So, like, my voice right now is using watts.
It is, in a way, yeah.
Wild.
And to give you an idea of the scale we're talking about here, the reference point for sound power, which is 0 decibels,
Okay.
that's equal to 1/1,000,000,000th of a watt.
Whoa. Okay.
So we're dealing with some seriously tiny amounts of energy here, but our ears are incredibly sensitive.
That's amazing. And here's what I think is super cool.
Yep.
Those pressure waves, they can actually make things move.
Oh, yeah.
Right? So when sound hits something, it makes these tiny vibrations.
It does. Absolutely.
Walls, windows, even our bodies vibrate a little when sound waves hit them. Isn't that crazy?
It's true. And that actually leads us to sound absorption.
Okay.
Some materials are basically like sound sponges.
Oh, okay.
They soak up that energy and turn it into a teeny tiny bit of heat.
So that's why some rooms are like really echoey
Exactly.
and then others are like super quiet.
Precisely.
Okay.
The materials make all the difference. Like, think about shouting in a bathroom with all those tiles versus in a library full of those big, comfy chairs.
Oh, yeah. Huge difference.
Huge difference. The tiles are just bouncing all that sound back at you. That's the echo.
Right.
But those chairs, they're like, sound, you're done. They absorb it.
Oh, I like that. I like that. They're like, nope, you're done.
Exactly, yeah. And there's actually a term for how much sound a material can absorb.
Oh, is there?
Yeah, it's called the absorption coefficient.
Oh, okay.
It's basically a percentage, and it tells you how much of the sound is getting absorbed versus reflected back.
So like a higher absorption coefficient basically means a quieter room, right?
That's it. You got it.
Okay. But now I'm curious. What about the sound that's trying to get through a wall or a floor? Like from the other side.
Oh, yeah.
That's where things get kind of tricky, right?
It can be a bit more complex, but it might help to picture it like, I don't know, throwing a tennis ball at a bed sheet.
Okay, I can see that.
Some of that energy bounces back at you.
Right.
Some of it gets absorbed by the sheet, and then some of it goes right through to the other side.
Yeah, yeah.
That's kind of like sound transmission in a nutshell.
Okay, and I remember that the source material talked about a wall, like a super thick concrete wall, like 12 inches thick.
Yeah.
I was like, man, that's got to be the ultimate sound blocker.
You'd think so, right?
But then it said that it's not always practical, and it's not always like the most effective way to do it.
That's because, yeah, you're right, mass is important.
Yeah.
But it's not the only thing. Like, you can actually get amazing sound isolation by using multiple layers of lighter stuff with air spaces in between. Almost like I don't know, like a soundproofing layer cake.
A soundproofing layer cake, I like that.
Yeah.
So it's like you're making this like maze for the sound waves to go through, right?
Exactly. Make it hard for them to find their way through.
And then they lose energy along the way, right?
Yeah.
Okay, so speaking of that, I always see like STC and FSTC ratings on building materials. What do those numbers actually tell us?
So those stand for Sound Transmission Class, STC, and Field Sound Transmission Class, FSTC.
Okay.
And essentially, the STC is a measure of how well a wall, a partition, whatever,
Yeah.
how well it reduces sound transmission, but it's done in like a perfect lab setting.
Oh.
While FSTC, that's more like a real-world test.
Okay, got it, got it. So
Yeah.
higher the number,
Yeah.
better the sound isolation.
Yeah. In theory, yes. But there's a little catch.
Uh-oh.
The STC test really zeroes in on those middle range frequencies.
Okay.
Like, think about human speech, that kind of range.
Okay.
Doesn't necessarily mean it's great at blocking out those super low sounds.
Oh,
You know, the rumbly ones?
Yeah. Like those can be super annoying. Like you could have this wall that blocks out voices,
Exactly.
but then you just hear the boom, boom, boom from the neighbor's music.
That's the worst. And that's the thing with soundproofing. It's not always straightforward.
Yeah, it's not just like one size fits all, right? You got to think
Yes.
about all those different frequencies. So how do we deal with those low sounds and how our ears like actually hear stuff?
Right, right. That's where it gets even more interesting. The source material mentions something called noise criteria, NC, and room criteria, RC. And this is all about how different frequencies mess with our perception of sound, like how we experience it.
Oh, interesting. So two sounds can have the same like dB level, but they feel totally different to our ears.
Yep, you got it.
Like a loud hum versus a sharp sudden sound.
Yes, exactly. One's just annoying, the other can be startling.
Right. They're both loud, but
Yeah, they're just different.
it's like a different kind of loudness.
And that's what NC and RC curves help us with. They help us design spaces that actually sound good.
Oh, wow. This is so much more to acoustics than I thought.
It's a whole world.
It's like a balancing act. You got to figure out the decibels, the absorption, the transmission loss
It's true.
to make a space that actually functions and feels good to be in.
Yeah.
That's a lot.
It is, and we haven't even gotten to impact noise yet. The sounds that travel through the building itself.
Oh man, impact noise. Don't even get me started on like those upstairs neighbors. It sounds like they're herding elephants up there.
I know, right?
So what's the deal with impact noise? Why is it so hard to block?
That's a great question, and it has to do with how the sound travels. It's different than just sound waves moving through the air.
Right.
It's about vibrations going right through the materials themselves, you know?
Oh, okay.
Like, think about footsteps on a floor above you or someone hammering on a wall, that kind of thing.
Right, right.
That's impact noise.
So even if you've got like amazing soundproofing on your walls,
Yeah.
those vibrations can still like sneak through.
They can, it's tricky. And here's something that might surprise you. Concrete floors, which you'd think would be awesome at blocking sound.
Yeah, they're heavy.
They're terrible at dealing with impact noise.
What? Really? Why is that?
It's because concrete is so dense. Like, it's great at stopping those airborne sounds,
Okay.
but vibrations just shoot right through it. It's like, imagine banging on a giant drum. That's kind of what's happening.
Okay, so what do you do? Like extra thick carpet?
Adding some kind of resilient layer can make a huge difference. Carpet, a floating floor, even that special underlayment stuff.
Okay.
All those can really cut down on how much impact noise gets through.
So it's like putting a cushion between you and the noise.
Exactly. And it's super important in apartment buildings, any place with multiple floors, really.
Makes sense. You don't want to hear everyone moving around above you.
Exactly. Now, there's another sneaky way that sound gets around, and the source material called it flanking transmission.
Flanking transmission. That sounds kind of intense.
It's like sound's way of staging a secret mission to get around your defenses.
Okay, I'm intrigued. Tell me more.
So, Flanking transmission, it's when those sound waves find these like little back roads, you know?
Okay.
They bypass even the best sound barriers you've set up.
Like what? Give me an example.
Okay, so think about ductwork.
Right.
Those little gaps in walls, even the space above your ceiling tiles, sound can travel through all that stuff.
So you could have like top of the line soundproof walls, but if there's a gap somewhere,
Game over. The sound's gonna find it.
ugh, that's so frustrating.
It's like having a fortress, but you forgot to close one tiny window. The source material actually had a good example about this. Perimeter radiators in office buildings,
Right, right.
they can cause this kind of flanking because they're installed right up against the wall.
Yeah.
If the wall doesn't go all the way up to the ceiling above, sound can just travel right over the top.
Oh no. So it's like a shortcut for the sound.
Exactly.
It totally bypasses your soundproofing.
Right.
Man, that's kind of wild.
Yeah, sounds sneaky like that. So you really got to think like sound to stop it.
Okay, so how do we outsmart it? How do we stop those flanking maneuvers?
Well, you got to seal up those gaps, first of all.
Yeah.
Extend those walls all the way up to the real ceiling. And then using sound dampening material and things like ductwork, that helps a lot. You're basically closing those loopholes.
So it's a combo of like blocking, sealing, and then absorbing, right?
Got it. You got to be thorough.
Man, it's like you got to outsmart those sound waves.
Exactly. It's like a game of acoustic chess.
Yeah.
Anticipate where they might try to go and cut them off.
That's a great way to put it. Okay, so we've talked about keeping unwanted sound out.
Yeah.
But what about making spaces sound good? You know, like what makes a room sound pleasing? The source material called it reverberation time.
Oh, yeah.
Sounds kind of fancy.
It's a fancy term for how long it takes for a sound to fade away in a space.
Okay, so like after the sound stops.
Exactly.
Right there.
Imagine you clap your hands in a giant empty gym
Oh, yeah.
versus clapping in a small room with like furniture and stuff.
Big difference.
Huge EE difference, right? The sound hangs around in that gym forever.
Yeah, it's like this echoey.
Exactly. That's reverberation.
Okay, so longer reverberation time, that means a more echoey space?
You got it. Longer time, more echoes. And here's the thing. The ideal amount of reverberation time, it actually changes depending on what the space is used for.
Oh, that makes sense.
Like a concert hall, it needs a longer reverberation time.
Okay.
Gives you that rich sound.
Yeah, yeah.
But a lecture hall, you need it to be shorter so you can actually hear the speaker. Interestingly, the source material actually said that a dimly lit restaurant with hard surfaces will feel noisier because of this.
Oh, that's so interesting because you can't hear yourself think.
It's true. All that echo just bounces around.
It's too much.
Yeah.
So how do architects like control that? It's just the materials they use?
Materials are huge EE, yeah. Like hard surfaces, they're going to make that sound bounce around more.
Right, okay.
But those softer materials, things that absorb sound, they'll cut down on those echoes. Carpets, curtains, those fancy acoustic panels, that kind of stuff. The source material pointed out that most materials are pretty good at absorbing those high frequencies.
Okay.
But you need those really thick, dense materials to deal with the low-end stuff.
Right, got to tackle it all. So it's about like finding that sweet spot, I guess.
Exactly. Too much reflection, and it's echoey. Too much absorption, and it sounds dead. Gotta get that balance right.
It's an art.
It really is. And architects use all these cool tricks to get it right. Like where they put those sound absorbing panels, what kind of furniture they use. Even the shape of the room makes a difference.
Whoa, the shape of the room.
Oh, yeah. And remember how we were talking about how sound acts differently at different frequencies? That comes into play here, too.
Oh, right.
Some materials are better at tackling certain frequencies than others.
So it's not just how much sound is absorbed, but what kind of sound.
Exactly. And that's super important when you're designing a space for music because music uses all those frequencies, right?
That's true. I never thought about it like that.
Yeah, think about those recording studios with all those crazy shaped panels on the walls.
Yeah.
Those are there to control all of that. They're like fine-tuning the sound, like adjusting the EQ on a stereo.
That's a perfect analogy.
So you're basically shaping the sound to be exactly how you want it.
Wow. Okay. So reverberation time is key.
Mm-hmm.
But are there any other, like, acoustical villains that we need to look out for?
Oh, you bet. Echoes, for one. We've all heard those. And then there's something called flutter echo and something called sound focusing. Those can be tricky.
Sound focusing. That sounds kind of scary.
Imagine like a sound laser.
Okay.
It happens when sound waves bounce off a curved surface, like a rounded wall or something.
Okay.
And all that sound gets concentrated in one spot.
Whoa, so instead of spreading out, it's like super loud in one specific spot.
Yeah, it's like that curved surface is acting like a magnifying glass for the sound.
That sounds like a recipe for disaster if you're not careful.
It can be,
Yeah.
especially in places where people are trying to talk.
Hmm.
The source material actually mentioned that large drywall surfaces and those wood veneer walls, they're notorious for this.
So what do? Just ban curved surfaces from buildings?
Huh. No, that would be kind of boring, wouldn't it?
Yeah, probably.
Luckily, there are ways around it. You can put sound-absorbing material on those curved parts that helps break up the sound. It's all about balance, really.
Right, because a space could look amazing, but if the sound is messed up,
It's ruined.
totally ruined. Okay, so then what about those echoes and those flutter echoes you mentioned? Those are different, right?
Yeah, so flutter echo is that annoying back and forth sound, like when you clap your hands between two walls.
Oh, yeah. It's like this weird...
Exactly, like a ping pong match in your ears. And those hard surfaces, they're usually the culprits.
Okay, so how do we stop the ping pong match?
Got to break up those parallel surfaces, add some angles to the walls, use different materials to mix things up, or just add some more of that sound-absorbing stuff. Anything to stop that back and forth.
So it's all about being clever with the design and the materials.
Exactly.
Yeah, this is really making me realize, like, sound is this invisible force, but we can actually control it. We can shape it with the right knowledge.
That's what's so cool about acoustics. And it's not even just the big stuff like walls and ceilings.
What else?
Even little things like where you put the furniture can make a difference.
Whoa, really?
Oh, yeah.
So you're telling me, like, my constant rearranging of my furniture, that could actually be helping the acoustics of my apartment?
You might be onto something. But let's not get ahead of ourselves. We've covered how to keep the bad sound out
Right.
and how to make the good sound good.
Okay.
But there's one more sound offender we got to talk about. All those mechanical systems in a building.
Oh, right. HVAC, plumbing, all that stuff.
Exactly. Those can be a real buzzkill if you don't deal with them right.
Oh, tell me about it. Like that constant hum from the ventilation, it can drive you crazy. The source material said you want those mechanical spaces at 75 VBA or less.
That's a good rule of thumb. Keeps things quieter in the rooms next to them. And you'll never guess what one of the biggest noisemakers is.
Let me guess. The ducts.
Good guess, but not quite. It's those fans.
The fans, really. They don't seem that loud.
You'd be surprised. They're like little noise factories. When that air gets pushed through the blades, it makes this uneven pressure.
Okay.
And that's what we hear as noise. And the faster it spins, the louder it gets.
So the airflow itself is creating the noise.
In a way, yeah. It's all about that turbulence. And the source material talked about how axial fans, they sometimes have these things called straightening vanes to help with that. It's like they direct the airflow to make it smoother. They even said that the closer a fan is to peak efficiency, the quieter it'll be.
Who knew fans were so complicated?
Right. It's a whole science. And there's this one type of blower. It's called a positive displacement rotary blower.
Okay.
Those things are LUD, like industrial strength loud. They need serious noise control, like silencers and stuff.
Wow. Okay. So maybe not the best choice for a quiet home office.
Definitely not. So besides keeping those blowers in check, how else do you deal with mechanical system noise?
Yeah. What are some of the strategies?
Well, you gotta tackle those sound waves, right?
Right.
So lining the ductwork with that sound-absorbing material, that helps. Using mufflers and silencers, and then doing things to stop the vibrations from spreading.
Okay, so break it down for me. Lining the ductwork, that's like giving it a cozy blanket to muffle the sound, right?
Exactly, like a sound cocoon for your ducts.
I like it. And it works, right?
It does. It absorbs those sound waves as they travel through. Oh, and here's a bonus tip from the source material. Sometimes you even got to wrap the outside of the ducts with insulation.
Really? Why would you do that?
To control something called, get this, break-in and breakout noise.
Break-in and breakout noise sounds intense.
It's kind of like it sounds. Break-in noise is like the sound from outside the duct that's trying to sneak in.
Oh, okay.
And breakout noise is the sound from inside that's trying to escape.
So it's a two-way battle to keep the sound contained.
Exactly. And if you're dealing with like a ton of noise across a bunch of different frequencies, sometimes you got to bring in the big guns.
Okay, what are the big guns?
We're talking a massive plenum.
Oh,
A
well,
plenum.
yeah.
It's like this big chamber, and you line the whole thing with thick sound-absorbing material. It's hardcore.
Wow, that's commitment to quiet. Wait, and then what about those mufflers and silencers you mentioned? Are those for specific things?
Yeah, those are like the targeted weapons. You use them near the noisy stuff, like fans.
Okay, so they're like strategically placed.
Exactly. And they're not all the same. They use a mix of sound absorption and these things called reactive elements.
Reactive elements. Sounds kind of sciencey.
It is kind of sciencey. They basically reflect the sound waves back to where they came from.
Oh, so it cancels out the noise.
Yeah, kinda. It's like acoustic jujitsu.
Yeah.
And those reactive elements, they're all different depending on what you're trying to quiet down.
So it's very customized. It's not just like a one-size-fits-all muffler, right?
Not at all. It's all very specific to the problem you're trying to solve.
Wow, that's so cool. Okay, and then the last thing you mentioned was vibration isolation. Is that as important as all this other stuff?
Oh yeah, super important. Remember how we were talking about vibration being a pain?
Yeah.
Well, vibration isolation is how we stop it from spreading.
Okay, so how do you do that?
You basically want to isolate the equipment from the building itself.
Oh, okay. So it's like giving those noisy machines their own little island to vibrate on.
Exactly. And there are all kinds of ways to do that. Springs, rubber pads, even these high-tech mounts.
It's like giving those vibrations a soft place to land so they don't shake the whole building.
Exactly.
Man, it's amazing how much goes into making a space that's actually comfortable sound-wise.
It's a lot more than people realize. And the cool thing is you can actually apply a lot of this stuff to your everyday life, even if you're not designing a concert hall or anything.
That's a good point. Okay, we've talked about keeping the bad sound out, make the good sound good, dealing with all those mechanical systems. But there's one thing I'm still curious about. Acoustical privacy.
Oh yeah, that's a big one.
What actually makes a space feel private, sound-wise? What do you have to think about for that? So like, how do you keep those private conversations actually private? What makes for good acoustical privacy, in a room or a building?
You've hit on a super important part of this whole acoustic design thing. It's not just about making things sound good, it's about making them sound right for the situation. And when we're talking privacy, we got to think about two main things.
Okay, what are they?
First, there's that airborne sound, the stuff we've been talking about, like voices traveling through the air.
Right.
But then there's those sneaky vibrations, the ones that go right through the building itself. We can't forget about those.
Ah, okay, yeah. So it's like overhearing a conversation happening next door versus hearing those thumps from the apartment upstairs.
Exactly. Two different problems, two different solutions. And, building codes actually get into this stuff.
They do.
Oh, yeah. They often have minimum requirements for something called the sound transmission class, that STC rating.
Okay, yeah. We talked about that a little bit before.
Right. So, a lot of codes say you got to have at least an STC of 45. That means a wall or a floor has to cut down that sound transmission by at least 45 decibels.
So higher STC, more privacy, basically.
You got it. More peace and quiet. And if you need things to be extra hush-hush, like in a confidential meeting room or between apartments,
Yeah.
you want to bump those numbers up even higher. Like aim for an STC between 50 and 55.
Oh, wow. Okay, so those higher numbers, those are for serious privacy situations. It's kind of cool how these building codes are secretly shaping the sounds of our lives.
They really are. And it shows that privacy isn't just about comfort. It's about security,
Yeah.
Creating a safe space.
Totally. Imagine a police interview room.
Exactly.
Or a therapist's office.
Yep, those places got to be private. And these days, with technology always changing, it gets even trickier.
How so?
Well, the source material even said that with those super powerful sound systems people have now, even a wall with amazing sound isolation might not be enough.
Oh, wow. So the sound can be so loud that it just overpowers everything.
Pretty much. It's a good reminder that we got to keep adapting.
So how do we do that? How do we stay ahead of the sound, so to speak?
Yeah.
What can you actually DO to make that sound transmission loss even better?
Well, it might sound simple, but mass is king. The source material was very clear about that.
So heavier materials are better for blocking sound.
You got it. Heavier is usually better when it comes to this stuff. Doubling the weight of a wall can make a big difference.
Okay, so those concrete block walls,
Yep.
poured concrete, that's where it's at.
Those are the heavy hitters. And here's a myth buster from the source material. Just adding more of that fluffy, sound-absorbing stuff that doesn't necessarily make a wall that much better at blocking sound.
Wait, really? I thought that was the whole point of that stuff.
It's a common mistake. See, those panels, they're great for how a room sounds,
Okay.
but they don't magically make a wall soundproof. It's got to be about the structure, too.
So you can't just slap some acoustic foam on a wall and call it a day?
Nope. Got to be smarter than that. It's got to be a combo of the right materials, the right design.
Give me an example. What's one way to actually make a wall better at blocking sound?
Okay, so even something as simple as how you install drywall can make a big difference.
Really? It all matters.
Oh, yeah. Like, if you just put two sheets of drywall right next to each other, yeah, you get a little improvement, but not much.
Okay.
But if you do what's called staggered stud construction, where the studs are offset,
Okay, I'm picturing it. I'm picturing it.
you get way better results.
So the studs aren't lined up. It's more like they're staggered, like bricks in a wall.
Exactly. It's about separating those layers, so they're not all connected in a straight line. That way they don't all vibrate together, which cuts down on the sound transmission.
Oh, that's so clever. It's like each layer of drywall gets its own little sound dampening platform.
That's a great way to think about it. And, the source material even said that you want to minimize the acoustic connection between those layers as much as possible.
Okay, so how do you actually disconnect those layers sound-wise?
Well, we talked about the staggered studs, but adding more airspace between those sheets of drywall, that helps a lot.
Okay, more air. Got it.
And then, if you want to get really fancy, put some of that fluffy fiberglass insulation in that gap.
Oh, okay.
That disrupts the sound waves even more. Bigger airspace, less connection, better sound isolation.
Music to my ears. Man, it's all these little details. It's like every choice matters.
It really does. But that's what's so cool about this stuff. With a little bit of know-how, you can really make a big difference in how a space sounds.
This whole deep dive has been amazing. I
Yeah.
feel like we've covered so much. From the basics of what Sound IS
Right.
to all these like ninja techniques to control it.
Acoustic ninjas.
That's us. I feel like I could tackle any sound problem now.
Right. That's the spirit. And that's the thing to remember. Sound might be invisible, but it's powerful. But we don't have to just let it control us, We can actually shape our environment so they sound good. A&D feel good.
It's all about that balance, right? Form and function. Well, on that note, I think we've reached the end of our acoustic adventure for today.
It's been a blast.
It really has. To everyone listening, remember, sound is everywhere, and it's powerful stuff. But now you've got the knowledge to understand it, and maybe even control it a little bit. So go out there and create spaces that sound amazing. Until next time, happy listening.